In this problem, we want to find the max and min values of this function on the closed interval from 0 to 2 pi. So because this is a closed interval and we're finding extrema, this is referring to absolute extrema. That is, we want to find the single highest y value, which is our max, and the single lowest y value, which is our min. Those extrema, because we're on a closed interval, could occur either at the critical values or at one of these endpoints. So we're going to start by finding critical values, which means we need to differentiate this function. So this means 7 times sine of theta cubed. So sine of theta is an inside function being raised to the power of 3. So when we differentiate sine cubed theta, we bring the 3 down and multiply it times the 7 to get 21. We have sine of theta all being squared times the derivative of sine theta by the chain rule is cosine theta minus the derivative of 7 times cosine squared theta. So for this, we pull the 2 down, multiply it by the 7 to get 14 times cosine of theta to the first power by the chain rule times the derivative of cosine theta. The derivative of cosine theta is negative sine theta, and a negative times a negative will become positive right there. Now this is going to exist for all theta because sine and cosine exist for all theta. So to find critical values, we'll set this equal to 0 and solve. And it looks like we can factor out both a cosine theta and a sine theta to get started on the solving. So I'm going to factor out a cosine theta and a sine theta, and we can also factor out a 7 as well. So that in my first term leaves me with 3 and 1 sine theta, so 3 sine theta. Plus here in my second term it leaves me with a 2. And that's it. Well, now it's factored. We can go ahead and set each factor equal to 0. If I just divide both entire sides by 7, 7 goes away. So I'm going to go ahead and set that cosine theta equal to 0, this sine theta equal to 0, and the last term is 3 sine theta plus 2. We'll set that equal to 0. And we need to solve those 3 equations to get the thetas, at least in the interval from 0 to 2 pi. So we need to find for what values of theta does cosine of theta equal 0 in between 0 and 2 pi. So let's go to a little circle over here. If we are only looking in between 0 and 2 pi, that just means that we start here and we go around like this, we get to pi over 2, we keep going to pi, 3 pi over 2, and 2 pi. Okay, so going around like that, cosine of theta equals 0 where the x values are 0, which is right here at pi over 2 and 3 pi over 2. So my two values of theta there are pi over 2 and 3 pi over 2. Okay, those are both critical values of the function. Sine of theta equals 0 where the y values are 0. And we actually have 3 values at which that occurs. Right here at 0, over here at pi, and then back over here again at 2 pi. Now 0 and 2 pi are endpoints anyway, so we'll plug those in anyways. But they are critical values, I suppose, as well. They are places where the derivative is 0. So we have 0, pi, oops, that was supposed to say 0 there, and 2 pi. So those are also critical values. And then where does 3 sine of theta plus 2 equal 0? Well, let's move the constants over to get sine theta equals negative 2/3. Where is sine theta negative? Okay. Going back to the circle, sine is negative where the y values are negative. So down here in quadrants 3 and 4, sine will be negative. And sine is a ratio of y to r, the y value to the radius. So this means the y is negative 2, and my radius value r is 3. So when I draw this, I'm going to draw it about like that, or so. So the y value right there is -2 and the radius is 3. And we want to find that exact value of theta. Well, technically the theta goes all the way from 0 over to that angle. And it's related to sine inverse, but it's not exactly sine inverse. When we do sine inverse, it gives us an answer between -π/2 and +π/2. So when I use sine inverse, it's actually going to refer me to that angle right there in red. That theta is sine inverse of -2/3, and it's actually a negative angle. So in order to get from this negative angle all the way around here to that positive angle, we have to add a little something to this sine inverse of theta. Let's see, if we were to add just positive pi, we were to do this angle, puts me at this negative angle here. If I add pi, I get right there. That's the opposite of this. Now this is not a solution, it's just where I get if I add pi to the red angle. Then we need to go a little bit further, but as you can see, these mirror each other, right? If we add pi, we're still going to have a y of 2 and a radius of 3. So this angle is the same as that angle, which is the same as that angle. Okay, so to make this angle right here positive, the positive of that angle would be, because sine inverse of -2/3 is negative, the positive of that angle would be negative, the negative of sine inverse of -2/3. So that's the positive value for that angle right there. This angle here is equal to double that positive value. So that angle right there in green, okay, is equal to double that. So to get this angle here in my third quadrant, we've got to have sine inverse of -2/3 is my starting point. And then to get from here all the way around, we have pi plus double the positive of the angle theta. So plus pi plus the double of negative sine inverse of -2/3. And now I can simplify this expression, and I'm going to label this is the one in quadrant 3, right here. Okay, but I can simplify this expression because we have a positive sine inverse of -2/3 plus pi. This is -2 times sine inverse of -2/3. So that sine inverse cancels with one of those. So we end up with pi minus sine inverse of -2/3, which is probably an easier way to say it anyways, because we have pi. If we start from here to here at 0, we go all the way over to pi, and then we add the positive value of the angle, which is the negative of sine inverse of -2/3. Okay, so that's one of my critical values. The other one is in quadrant 4. That's the other angle at which sine of theta is -2/3. Well, if I start here at this negative angle, at sine inverse of -2/3, I just need to make a full revolution around in order to make that angle between 0 and 2 pi. So we're going to have the angle itself, which is sine inverse of -2/3 plus a full 2 pi. So that's my other critical value. So we have quite a few critical values on that interval. So that gives us a total of 1, 2, 3, 4, 5, 6, 7 x or theta values to plug into the original function at which we would compare y values to see what's the largest and what's the smallest. 0 and 2 pi are already the endpoints, so I'm already counting those. Well, I have so many here. I'm going to label theta 1, theta 2, theta 3. Actually, no. Let's do the endpoint first. Let me change that. I'm going to do the endpoint 0 first. Let's call that theta 1. If I go in order of the thetas, the next theta I hit is pi over 2, so we'll call that theta 2. So the next one I would hit is pi. Then between pi and 3 pi over 2 we have this angle here, which is my this one right there. So we'll call that theta 4. Then we hit 3 pi over 2. Then in the fourth quadrant we hit that one. And then my last endpoint is that one. Don't have to go in order, but I just like to. So plugging in theta 1 into the original function, we'll have y equals 7 times sine cubed, let's see, theta 1 is 0, so sine cubed 0, and perhaps I should actually write theta 1 equals 0, there we go. So we get y equals 7 times sine of 0 is 0, so 7 times 0 minus 7 times cosine of 0 is 1, so minus 7 times 1, we get negative 7 for our first y value. Just because I'm going to have to re-find that number, I'm going to go ahead and highlight it. Then we plug in the second theta value, which is pi over 2. So sine of pi over 2 is 1, so that's 7 times 1 cubed, or 7. Cosine of pi over 2 is 0, so 7 minus 0. So we get positive 7 for that value of theta. Then theta 3 is pi. Plugging in pi, we have sine of pi. Sine of pi right here is 0, so my first term is 0. Cosine of pi is the x over the r, which is going to be negative 1. Now negative 1 squared is positive 1, so we still have negative 7. Then theta 4, that's where I have an interesting one. It's easier though to look at the diagram. So theta 4 is referring to that angle right there. That angle is referring to theta 6. So theta 4 is this angle right in there. So I'm going to use this diagram to find those values. In fact, it might be easier if we kind of blow up the diagram a little bit, at least that triangle. So that triangle for theta 4 looks something like this. The y is negative 2, the radius is 3. Now I'm going to need to find sine of theta and cosine of theta. Because I need cosine theta, I need this x value right there, so we'll use the Pythagorean theorem real quickly to find that x value. So we have negative 2 all squared plus that x is equal to 3 squared. So we have x is equal to the square root of 9 plus 4. Actually, it's minus 4 when we subtract. So square root of 5. Okay, so when we plug in this value, pi minus sine inverse of negative 2/3, we get y equals, plugging into here, 7 times sine cubed theta minus 7 cosine squared theta. So 7 times, for sine cubed theta, I'm going to find sine of theta and cube it. So for that, to find sine theta, I'm going to use my diagram over here. The angle is here. Sine is y over r is negative 2/3. So it's negative 2/3, and that's being cubed back to the original function. Minus 7 times cosine squared theta. Cosine theta is, we just found, x is, actually it's negative. So it's negative root 5, that x value there, over 3. And that is being squared. Right, yes, okay. And let's see, this comes to 4 No, 2 cubed is 8. And it's still negative. We retain the negative. 3 cubed is 27. Okay, negative root 5 squared is positive 5. So positive 5 over 9. And it looks like my common denominator will have to be 27 here. So I've got negative 56 over 27. Then 35 times 3. So for this, is that right? Yes, 35 times 3 is 105. So here I have minus 105 over 27. So we get 105, need to add 56 to that. We get 161. So negative 161 over 27. I don't believe that that is divisible. No. Negative 161 over 27. Okay, that's the exact value, but I did need that approximated value as well because I have to compare it to the 7s over here. So that rounds to negative 5 point, if we're rounding to 3 decimals, I believe, so negative 5.963. Negative 5.963. Okay, so that is the y value on the function at that critical value. We see how this goes. So you would plug in, let's see, theta 5. Theta 5 is an easy one. That's 3 pi over 2. Plugging in 3 pi over 2 into my original function, we would get 7 times sine of 3 pi over 2 all cubed minus 7 times cosine of 3 pi over 2 all cubed. You can get sine and cosine off of this graph. The only difference is that x in the fourth quadrant is positive, so that is positive root 5 right there. And you can get that y value there, and then you would plug in, that was theta 5, theta 6 is this other angle, yeah, that's what I was referring to. And then the last one, theta 7, is 2 pi, the endpoint. And you compare all these highlighted y values, and the largest is your absolute max, and the smallest is your absolute minimum.